Greetings, internet users. Rain is a natural phenomenon that we have all witnessed at some point.
It's truly fascinating to see droplets falling from the sky, sometimes in small quantities, and other times in abundance, even accompanied by mud, animals, and other strange rains.
We will explain the phenomenon of rain and whether it can also occur on other planets. Rain is part of the water cycle on our planet.
Water is found not only in oceans and rivers, but also in the atmosphere in the form of water vapor. If the relative humidity of the air does not reach 100%, water, mostly from oceans, but also from some lakes and rivers, turns into water vapor, which rises due to the heat of the sun's rays. When a sufficient amount accumulates at a certain altitude, it forms clouds.
But how are these clouds formed? Water vapor is an invisible gas.
The warm air lifts the gas until it reaches a certain altitude, usually above 2,000 meters, where it cools down and can no longer maintain its gaseous form. It then condenses at what is called the dew point, forming water droplets measuring between 0.0004 and 0.1 millimeters, or ice crystals.
In other words, it transitions from an invisible gaseous state to a liquid or solid state, and that's when we see the clouds.
It's similar to seeing our breath become visible in cold weather due to condensation, or the steam from a hot shower condensing in the surrounding environment due to the temperature difference.
What we see are always tiny water droplets, not vapor. Sunlight reaches these millions of microscopic droplets, reflecting all possible colors.
The mixture of all colors results in white, which is why we see clouds as white. However, there are times when there are so many droplets or ice crystals that sunlight cannot fully penetrate them, giving the clouds a grayish tone. So, when you see clouds in the sky, they are simply millions of microscopic water droplets or ice crystals suspended in the air due to their small size and the air currents.
Humid air is less dense than dry air, which makes clouds float.
They need to increase in size to fall to the surface, but that doesn't always happen.
The most surprising thing is that if we analyze how many water droplets exist in a cloud with a kilometer in diameter,
calculations show that there are about 300,000 liters of water suspended in the air. Nature continues to astonish us. The first question that comes to mind is why those clouds filled with water droplets or tiny crystals don't fall on us.
It's because the pressure at high altitudes is lower than on the ground.
Air currents ascend, and air always moves from high to low pressures.
The air currents compensate for their weight, which is known as hydrostatic equilibrium.
Pressure and gravity are balanced due to the cold and warm air masses being delimited by pressure. The clouds don't immediately dissolve. To form and maintain their shape for a certain period, clouds need condensation nuclei. These are other microscopic particles, even smaller, that often contain ash, mud, dust, combustion processes, organic matter oxidation, and even cosmic dust. The droplets in the clouds are usually around 0.02 millimeters on average and combined with these other particles, which are about 100 times smaller than the water droplets. Although clouds can change shape, disappear, or reconcentrate in a matter of hours, if we somehow captured a cloud and brought it to the surface, it wouldn't survive.
The pressure and temperature would cause those tiny droplets to evaporate.
The air is continuously rising to higher altitudes, forming vapor that we don't see and creating clouds.
Up there, many things happen.
The Earth's rotation causes cold and warm fronts in clearly delimited areas, forming high-pressure anticyclones and low-pressure cyclones. High-pressure areas are zones created by the heat of the sun, forming a bubble where humidity decreases and it doesn't rain,
except during local storms caused by low pressure.
When a cold front meets a warm front, a low-pressure area forms and cloudiness increases in a confined area. Humidity rises and droplets merge to form larger drops, thanks to condensation nuclei such as dust and ashes. However, for them to fall as rain, they must weigh enough and their mass should increase at least 1,000 times. Their size must exceed 0.5 millimeters, reaching a sufficient weight to overcome atmospheric updrafts and fall. Their velocity typically ranges between 8 and 32 kilometers per hour. During their long journey towards the surface, the drops can encounter more dust or even microorganisms that adhere and get trapped.
If the drops encounter a very dry environment along their path, they may evaporate. Convective precipitation occurs when the Earth's surface is very hot and there is cold air in the troposphere.
The lighter warm air tends to rise and, when it encounters the cold air, it generates large cumulonimbus clouds that result in rain accompanied by storms.
However, due to their localized nature, they don't usually last long.
An example of this is a downpour, where drops can rapidly grow up to 7 millimeters and fall intensely in a short period of time.
Orographic precipitation happens when humid air reaches mountains and must ascend further, leading to cooling and vapor condensation, forming clouds.
If multiple cloud masses combine combine, they can give rise to rain or snow if it's cold enough.
Warm front precipitation occurs when two air masses meet, one warm and the other cold. For example, when tropical air meets polar air, the warm mass slides above the cold one, and the boundary between the two masses leads to condensation and precipitation.
As you can see, rain occurs in various ways, always involving the movement of large cloud masses and changes in pressure and humidity, causing raindrops to undergo changes that make them precipitate to the surface. Although the water primarily comes from the oceans, when it falls to the surface, it becomes freshwater because only water evaporates, while salt, such as sodium chloride, does not evaporate. Now, let's explain strange rains.
And why do phenomena like mud rain or blood rain occur? This phenomenon occurs in countries near deserts, especially in Spain and southern France.
The Sahara Desert carries many suspended particles into the atmosphere, which then combine with water droplets in the clouds on what are called condensation nuclei.
This is common during periods of drought when dust has accumulated in large quantities.
The clouds take on a brownish color, and when it rains, the drops carry many desert particles, forming what is known as mud rain. One particularly curious case was the blood rain that occurred over the city of Kerala in 2001, which turned its streets red for 2 months. The residents witnessed what appeared to be raining blood.
Some scientists interested in the phenomenon wanted to analyze the rain.
Godfrey Lewis, a physicist from the Cochin University of Science and Technology, observed red cells under the microscope, but without DNA evidence. Hypotheses started to emerge regarding these red blood cells, one of which suggested that a comet had disintegrated nearby, and its remnants had bathed the atmosphere. There were even speculations about extraterrestrial substances. The mystery was eventually solved when it was discovered that it was due to spores from the alga trentipolia. Animal rain is not common and is an extraordinary phenomenon typically associated with storms or strong winds. According to the French physicist André-Marie Ampère, these winds, usually tornadoes, can transport animals over long distances and then drop them elsewhere. The winds often capture migratory birds or even frogs and fish from ponds. Sometimes these animals have fallen within large blocks of ice, indicating the extreme cold at higher altitudes. What is not fully explained is how some animals manage to reach the ground in perfect condition. It rains on other planets, but in a different way. In our solar system, we know that it rains sulfuric acid on Venus, which is a combination of lead and sulfur particles.
This would not be pleasant for any spacecraft passing through a cloud front.
We also note that this rain evaporates before reaching the ground due to the intense heat. On Mars, in addition to the scarcity of clouds, it cannot rain because the atmospheric pressure is so low that water quickly evaporates.
On Saturn and Jupiter, we know that it rains diamonds due to the breaking apart of methane atoms by electric storms.
When these diamond particles combine with carbon in their dense atmosphere, they solidify. Titan, Saturn's moon, is one of the few places besides Earth where liquid rain occurs.
However, the liquid is not water, but methane. Titan has a methane cycle similar to Earth's water cycle.
Earth's water cycle is extraordinary, involving evaporation, condensation, precipitation, infiltration, and runoff. However, human activity is altering the water cycle due to climate change, resulting in periods of drought, intense floods, rising sea levels, temperature changes, deforestation, and desert expansion. These changes have led to extreme weather events and the spread of diseases. If we continue with polluting industrial activities, contaminants can be transported into the atmosphere, causing sulfuric acid rain like on Venus.
In this case, it would reach the surface.
Our beautiful planet Earth should be a place where progress does not destroy nature but coexists with it. Rain is a beautiful and soothing phenomenon. Even the sound of rain, when it occurs moderately, enriches crops, reservoirs, and helps nourish the land and plants, continuing their natural cycle. If you enjoyed this video, please like, subscribe, activate the notification bell, and leave your comments.